Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul Tickler. As usual, we first come to its statement. Okay. The light from a nearby star is observed to be shifted toward the blue by 2%. That is, F observer is equal to 1.02 F naught. Is the star approaching or receding from Earth? How fast is it moving? Assume motion is directly toward or away from Earth so as to avoid superluminal speeds. Okay. Now we come to its solution, but before its solution in a proper manner, we go through some snapshots which will make a foundation regarding solution of our problem. Okay, so first snapshot is regarding Doppler effect. Okay, Doppler effect, electromagnetic waves, source approaching observer, frequency measured by observer, speed of light in vacuum, frequency measured in rest frame of source f naught, while f is the frequency measured by observer, u is the speed of source relative to observer, and c is the speed of light in vacuum. Now two versions of Doppler effect are given. One version is approaching mode and second is receding mode. Okay, source or observer approaching. In this case, f will be equal to 1 plus beta over 1 minus beta under root into f naught. And in case of source or observer receding, f will be equal to 1 minus beta over 1 plus beta f naught. Okay. Next, these two versions have been explained in a relatively more precise manner. Okay, f is equal to 1 minus beta square under root over 1 minus beta into f naught. This becomes equal to 1 plus beta over 1 minus beta whole under root into f naught. Okay, this is in accordance with the formula a square minus b square is equal to a plus b into a minus b. Okay. This is approaching case, and receding case is f is equal to 1 minus beta square over 1 plus beta into f naught, and this alternatively becomes equal to 1 minus beta over 1 plus beta whole under root into f naught. Okay. Now we come towards the speed parameter. Okay. If the relative speed between frames is v, the contracted length L and the proper length L naught are related by L equal to L naught into this L naught over gamma, where beta equal to v over c is the speed parameter and gamma equal to 1 over 1 minus b square under root is the lower end factor. Okay. Next snapshot is about electromagnetic waves. Okay, spectrum of electromagnetic waves. It will also be used to some extent in this problem. Okay. Violet, blue, green, yellow, orange, red. Okay, red has wavelength from 620 to 750 nanometer, while violet is from 380 to 450 nanometer. Okay, this is another version of a spectrum of electromagnetic waves. Okay, approximate correspondence between wavelengths of visible light and color. Wavelength range in nanometer. Color description. Okay, violet, blue, green, yellow, orange, red. Violet is from 400 to 430, while red is from 625 to 700. Okay, this is another version of a spectrum of electromagnetic waves. Now, dear students, we come towards blue shift and red shift. Okay, because in problem it has been asked. Is the star approaching or receding from Earth? How fast is moving? The light from... Actually, answer to this will be covered by this discussion, that difference between red shift and blue shift. Okay. So now we are going to discuss a difference between a red shift and blue shift. Okay, some part of this explanation has been chosen from the book Modern Physics by Paul Tipler, and some part has been selected from internet Wikipedia. Okay, since the general expression connecting the frequency f and wavelength lambda of light is c equal to f lambda, the shift is toward longer wavelengths, as red is on the longer wavelength side of the visible spectrum. So the red shift is used to describe a receding source. Now we come towards red and blue spectrum description. Okay, this is red and blue. Okay, red 620 to 750, while blue 450 to 495. Okay, blue is towards shorter wavelength and red is towards larger wavelength. Okay, from second version of this description, blue is in between 430 to 485 nanometer, while wavelength of red is from 625 to 700 nanometer. Okay, so red is of larger wavelength while blue is of a shorter wavelength. Okay, that is why we have shown this. Okay, similarly blue shift describes light emitted by stars that are approaching us. Okay, for approaching us blue, while far receding red, typically ones relatively nearby in our galaxy. Dear students, we discuss a little more about red shift and blue shift. Okay, red shift and blue shift describe the change in the frequency of a light wave depending on whether an object is moving toward or away from us. When an object is moving away from us, the light from the object is known as red shift, and when an object is moving towards us, the light from the object is known as blue shift. This is some more explanation. Okay, in physics, a red shift is an increase in the wavelength and corresponding decrease in the frequency and photon energy of electromagnetic radiation such as light. The opposite change, a decrease in wavelength and simultaneous increase in frequency and energy, is known as a negative red shift or blue shift. Okay, blue shift is negative red shift and both are opposite to each other. Okay, now using this, okay, what we are going to use, we are just applying a Doppler effect. Okay, using f observer over f naught equal to 1 plus beta over 1 minus beta. This implies that value of this is given in the statement. Okay, once again we move to statement. Okay, this from here, when we take f observer over f naught, then it will become equal to 1.02. Okay, this is the situation that we have used 1.02 in place of f observer over f naught. Okay, using f observer over f naught equal to 1 plus beta over its value is put 1 plus 0.02 is equal to 1 plus beta over 1 minus beta. Okay, now what next? We are taking square on both sides. Okay, its square will become equal to 1.04, while these factors will become out of under root. Okay, under root will be cancelled because square of under root cancels under root. Okay, because under root is 1 by 2, power 1 by 2, and hence power 2 of power 1 by 2, 2 is cancelled by 2. Okay, so 1 plus 0.4 equal to 1 plus. Next, what we will do, this 1 minus beta will be multiplied with this, and this factor will be shifted on other side of equality, and their signs will be reversed. Okay, and then just simplification. After simplifying, beta has become equal to this, and we know that beta, what is beta? Beta is speed parameter v over c. So v over c is equal to this, and we know that value of c is 2.998, so v will be equal to this into c. So by using value of c, that is 2.998 into 10 raised to the power 8 meter per second, our v will become equal to 5.88 into 10 raised to the power 6 meter per second. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.